Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to electromagnetic theory. In the previous video we discussed about electromagnetic waves based on the two fundamental laws that govern the generation of electromagnetic waves. First, Faraday's law of electromagnetic induction, and next is Ampere's circuital law. So that we discussed. In this video we are going to discuss some basic properties of electromagnetic waves. So a basic review of the definition of electromagnetic waves is that it consists of sinusoidal variation of electric and magnetic fields which are at right angles to each other. They oscillate, they vibrate in mutually perpendicular planes, and they are also perpendicular to the direction of propagation of the electromagnetic wave. So whenever there is a change in electric field, there will be a change in magnetic field, and whenever there will be a change in magnetic field, there will be a change in the electric field, and they are the amplitude of the electric and magnetic field can be expressed through sign expressions. Now, some of the basic properties of electromagnetic waves. So first, as I said, the two fundamental laws, Faraday's law and Ampere-Maxwell law, which was previously the Ampere-circuital law. Maxwell introduced the concept of displacement current, and then it became the modified Ampere-circuital law or Ampere-Maxwell law. So the basic principle is that the electromagnetic waves, they are produced by either accelerated or oscillating charges or by variable current, changing current. So either a change in electric field through accelerated oscillating charges, or a change in magnetic field, magnetic flux, due to changing current, that can produce electromagnetic waves, because a change in one parameter affects the other. A change in magnetic field will cause a change in electric field. A change in electric field will cause a change in magnetic field. Why? Because each one is related to the other. So here, as we can see, the Faraday's law, which states that the EMF induced, which is expressed as the line integral of electrostatic field, that is related to minus n d phi b by dt, which is the rate of change of magnetic flux with respect to time. So electric field is related to integral of electric field, line integral is related to rate of change of magnetic flux with respect to time. So a change in one affects the other. Here also it is the line integral of magnetic field around any closed path, closed line integral, that is equal to mu 0 I plus id, displacement current, where displacement current id is equal to epsilon 0 d phi by dt, where epsilon 0 is the absolute permittivity. And here the line integral of magnetic field, that is related to the rate of change of electric flux with respect to time. Here line integral of electric field is related to rate of change of magnetic flux. Here line integral of magnetic field is related to rate of change of electric flux. So as I have already we have discussed in the previous video, again I am repeating it here. Whenever there is a change in one of the parameters, electric field or magnetic field, both time varying, it will cause a similar disturbance, a similar change in the other parameter. Change in electric field causes a change in magnetic field. Change in magnetic field causes a change in electric field, and it can be, it can come into effect because of accelerated or oscillating charges or variable or changing current. So that is the first fundamental property of electromagnetic waves. The second property, which is that both the electric and magnetic fields they are in mutually perpendicular planes. They vibrate or they oscillate in mutually perpendicular planes which are at right angles to each other, and this movement, this vibration or oscillation is also perpendicular to the direction of propagation of the wave. This. So here, as we can see, here the electric field, it is in the xy plane. Okay, the electric field, it is in the xy plane, and the magnetic field, the blue one, the electric field blue one, it is in the xy plane, and the magnetic field, the red one, it is in the xz plane. Okay, electric field blue one in the xy plane, it is vibrating or oscillating, and the changes in amplitude occurs along the y-axis, positive and negative. The change in magnetic field, it happens along the z-axis, positive or negative. The electric field is in the xy plane, the magnetic field is in the xz plane, and the direction of propagation of the wave is along x-axis. So xy plane, xz plane mutually perpendicular to each other, and also it is perpendicular to the direction of propagation of the wave, the electromagnetic wave. So that's why, for this specific reason, the electromagnetic waves, they are transverse in nature. Okay, they are, the electromagnetic waves, it is transverse in nature, because both the components of the electromagnetic wave, the electric and magnetic field, they oscillate in mutually perpendicular planes, and they are perpendicular to the direction of propagation of the wave. The three parameters, they are in mutually perpendicular directions. Okay, then the another property, which is the oscillations of electric and magnetic fields, they have no phase difference between them. They happen in the same phase. They attain their respective maximum values and minimum values at the same place and at the same time, which is evident through these equations. So here the electric field is represented as the time varying electric field E is equal to E0 cos kx minus omega t, where E0 is the amplitude. Okay, E0 is the amplitude. So this is the positive maximum value and this is the negative maximum value. Here k is the wave number, which is 2 pi by lambda, where lambda is the wavelength, and omega is the angular frequency, 2 pi f, 2 pi by t, and t is the particular instantaneous time. And here x comes into this place because the direction of propagation of wave is along the x direction, that's why x. And here for the magnetic field, this is the positive and negative, amplitude in the positive and negative direction, plus b0 and minus b0, and the same things. And here, as you can see, there is no phase difference between the two waves. Okay, there is no lag or lead. Okay, there is no lag or lead. Each of these waves, they are in the same phase and they attain their respective maximum values E0 and B0 in their respective planes along the y and z axis at the same time, and they are in the same phase. They start from 0 at the same time, they attain maximum values at the same time, and they again cross 0 at the same time. During the negative half cycle also same thing. The minimum value they attain at the same time, and again they go to 0 at the same time. Okay, so they have 0 phase difference between them. Okay, then another property, which is in free space, that is in air, all electromagnetic waves, they travel with the same speed, which is the speed of light, 3 into 10 to the power 8 meter per second, and it is expressed by the expression 1 by root over of mu 0 epsilon 0, where mu 0 is the absolute permeability 4 pi into 10 to the power minus 7, and epsilon 0 is the absolute permittivity 8.854 into 10 to the power minus 12. Okay, so in free space in air, all electromagnetic waves, they travel with a velocity of 3 into 10 to the power 8 meter per second, which is expressed as 1 by root over of mu 0 epsilon 0. Mu 0 being absolute permeability of the medium, that is air, and epsilon 0 is the absolute permittivity of the medium, which in a way reflect their ability to transmit electric and magnetic fields through the air, free space. And whenever they are traveling through any other medium other than free space or air, the speed of the electromagnetic wave in any other material, dielectric material, it is given by 1 by root over of mu epsilon, where mu is the permeability of that particular material and epsilon is the permittivity of that particular material. Mu is equal to mu 0 mu r, epsilon is equal to epsilon 0 epsilon r, where mu r and epsilon r are the relative permeability and permittivity. Okay, mu r is relative permeability, epsilon r is relative permittivity. And this speed of electromagnetic wave in any other material, it will always be less than c, that is less than 3 into 10 to the power 8 meter per second. Okay, and then another important property is the amplitude ratio, the maximum values of electric and magnetic fields, that is E0 by B0, that is equal to same c, 3 into 10 to the power 8, which is equal to 1 by root over of mu 0 epsilon 0, absolute permeability and absolute permittivity. So the amplitude ratio, the maximum values in both the directions attained by the electric and magnetic oscillations or waves, that ratio is equal to 3 into 10 to the power 8 c. And another important property is that the electric vector, this one, of the electromagnetic wave, that is responsible for all optical phenomena. Okay, and it is particularly used in fiber optic communications, in optoelectronic sensors, transducers. This particular concept is used, and this electric vector of the electromagnetic wave, that is called as light vector, and it is responsible for all optical phenomena, and it is particularly utilized for designing of specific transducers and detectors and also in optical communications. Okay, so here are some of the basic properties of electromagnetic waves. There are other properties also which we'll discuss in a separate video. Okay, so these are some of the basic fundamental properties of electromagnetic waves. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.